In exercise 2, we have a money market fund that pays a nominal rate of interest of 9.3% convertible semi-annually. And we want to find an equivalent nominal rate that's convertible monthly. So since the rate is 9.3% and it's convertible semi-annually, that means twice a year, n equals 2. So that means that 9.3% divided by 2 is the effective rate per half year. So I've done my timeline in half years, so this corresponds to 1 year. I just made up an amount to start with, let's say $1,000, and I want to know how much money will I have at the end of the year. Well, at the 6-month point at t equals 1, I multiply by 1 plus the nominal rate divided by n, which is 2, to give me the amount in the account at t equals 1, and then I do the same to get the amount at t equals 2, and so I have $1,095.16 at the end of the year, assuming a nominal rate of 9.3% convertible semi-annually. Now, I want to find a rate that's equivalent, that's convertible 12 times a year. So I'm going to make a guess. I'll say 8%, and I'll start with the same initial deposit of $1,000. I do down my timeline in months, so 1 year corresponds to t equals 12, and at the end of each month I add in interest, which I get by multiplying the previous balance by 1 plus the nominal rate divided by 12. And I do that all the way down to the end of the year. And if the nominal rate was 8% convertible monthly, then my ending balance would be 1,083. I want to find the rate at which I get the same balance as I did under the 9.3% convertible semi-annually. So I want the difference between the 1095.16 and the 1083 to be 0. So I've computed that difference there. And then I just have to do a solver or a goal seek. So I'll do a solver, and I want the difference, which is this cell, which is G13, to be equal to 0, and by changing the nominal rate to, and I do solve, and it finds a solution. And so 9.125 would be a rate convertible monthly that's equivalent to 9.3 convertible semi-annually.